Hello everyone and welcome to yet another interesting lecture, Linear and Binary Search Methods, in our lecture series Data Structure and Algorithms. I am Dr. Mangesh Joshi from Department of Mechanical Engineering. In today's session, we will explore searching techniques, especially linear search and binary search. These are fundamental concepts used to retrieve data efficiently, and they form the basis for more complex algorithms, right? So without wasting our time, let us begin with introduction to searching. So searching is the process of finding the location of target value within a data structure. In previous videos, in introductory lecture, I have given you the example, right, of fridge. So you have stored the data or the items in fridge. So searching process, that is the process of finding the location of item within a data structure. It is nothing but termed as searching. Use cases can be information retrieval. We want to access some specific information like searching a word in a document or a record in a database, right? Then data processing, when we filter or locate specific values in Excel sheet. Decision making in algorithms like in games or optimization problems. So the analogy in this case is simple, like you use control plus F to find the values in a document, right? So we need efficient methods to quickly locate data in our programs. So let us come to necessity of a robust search mechanism. So why do we need a robust search mechanism? Because you know that time matters, speed matters, time matters, right? If we use a poor searching method, even a small data set can slow down the performance. In large scale systems like e-commerce or databases, searching efficiently can significantly reduce computational time, and it reduces down the frustration level of user. For example, if a computer system loads very slowly or searches very slowly, so what happens? User gets frustrated, right? So to avoid this situation, you need to have a robust search mechanism. Choosing the right method depends on the data structure, size of the data, and whether the data is sorted and or not. So it is important to understand the strengths and weaknesses of each method. So why this necessary to have a robust search mechanism? First point is increasing data volumes. Today's applications handle massive datasets. Think of a social media, e-commerce platforms like Amazon, Flipkart, or scientific databases, that is Scopus, right? Or Web of Science. So without an efficient search system, retrieving information becomes slow and computationally expensive. So that's why this topic is very, very important. Second point is speed and responsiveness. Users expect real-time or near instantaneous responses. Example, typing in a search box should yield results in milliseconds. Slow searches frustrate users. Everyone has used Google search bar. So you know that it gives you results, so many results in milliseconds. So that's the speed a user expects. Then scalability. A good search mechanism should maintain performance even data grows. Linear search may work for small datasets, but it fails to scale well for larger ones. Then next, accuracy and relevance of searching. The results should not only be fast, but it also needs to be accurate, correct, and relevant. In applications like medical databases, legal systems, incorrect results can have serious consequences. That's why, depending on the situation, accuracy and relevance is very crucial factor. Then intelligent decision making. Many AI and machine learning systems rely on efficient search methods, that is finding nearest neighbor, KNN algorithm, K means clustering, etc. Efficient searching directly impacts the system effectiveness. Sixth point, backend optimization. Search mechanisms are used not only in user interfaces but also in backend operations like database indexing, memory management, and file handling. So for all these purposes, robust search mechanism is necessary. Real life examples, Google search engines uses highly optimized search algorithms over billions of index pages. Amazon product search filters thousands of listings instantly based on the keywords provided by the user. Operating systems searching for files in directories or managing memory allocation involves efficient search routines. So these are the different examples. Let us begin with the first searching method is linear searching method. So linear search is the simplest searching algorithm. In this approach, we go through each element one by one, comparing it with the target value. If the target target match is found, we return the index or position. If not, we move to the next element. Repeat until item is found or list ends. Let us understand this with a simpler numerical example. So to implement the linear search algorithm, we need an array, a collection of values we want to search through. So this is an array, for example, 10, 20, 30, 40, 50. Then we require a target value, the specific value we are trying to find out. Let us say target is 30. A loop go through the array from start element to the last element, checking each element till the value is found. Next, fourth is a condition. If else if statements. Compare each current value with the target. So this is that statement. If ARR of I compares with target, then return the index I. And finally, if all the elements are searched, return -1 if not found. If the loop ends without a match, return -1, meaning value is not in the array, that is no value found. This is the example. 12, 45, 67, 23, 89 is the array. Target element is 23. So we are going, so this is the logic given, starting loop I equals to 0 to n minus 1, which is 4. If ARR of I, so ARR of I is 12, compares with the target, which is 23. If it is yes, then return that index. If it is no, then increment the I. So since it is not matched in the first case, increment the I. So I will become 1. So it will take 45. Comparing with target 23, not a match. Then I++ 67, compare with target, not a match. Then I++ 23 with 23, found match. Then return the index 3. That is 0, 1, 2, 3. So it will return the index that it is the requested element or target element is found. This is the code which can be used. It is very simple. You can just go through it. Linear search, which accepts the array, integer array. N represents the number of elements in the array and the integer target. So same logic is written over here. If ARR of I compares with target, then return I. If going through all the values, it is not found, then return -1, right? Else return I, correct? So it will return an integer to calling function. So here that is called linear search. So it will result either the index if found or -1. So if it is not found, then the result will be -1. So here it is checked if result not equals to -1. So element found at this location. Else it will printf element not found. Likewise. So this code is very easy to understand. Linear search. Key points in the linear search. Best case time complexity is 1. That element is found at the beginning itself. Worst case complexity is n. You have to go through all n elements. Element is at the end of the list or not present in the list. Space complexity is 1 as no extra space is required. Works on both sorted and unsorted list. This is the advantage of linear search. Easy to implement but not efficient for large datasets because it is difficult to compare each value if the data sets are large, right? So these are the key points for linear search. Method number 2, binary searching method or binary search method. So as per definition, binary search is a divide and conquer algorithm that works on sorted lists only. If in the examination or interview they ask you about distinguish between linear search and binary search, then you can quote this point that it works on sorted list only. It checks the middle element and then decides whether to search on the left or the right half, narrowing the search space with each step. So for example, let us see the step of binary search. So you require initialize point parameters like set low, suppose let's say example to understand it better, 2, 4, 5, 7 and 10. This is the sorted array given to you and you have to search target value of 7. Okay, so low value is having index 0, high value is having index n-1. Since there are 5 elements, n-1 is nothing but 4. So low and high you have set. Then second step is find the middle. That is nothing but 0 plus 4 by 2. So it comes 2. So mid index is 2. 0, 1, 2. So this is the middle point, right? Compare the middle element. If middle element is equal to target, return the index. Now we are searching for 7. But suppose in the case we are searching for 5. So if middle element is target, so in that case we will be returning that index that is 2, right? But in this case, since middle element is lesser than the target element. So this is the case. Middle element is less than the target element. Search the right half. So we will be searching on this side, right? Because target value we have to search is 7. Repeat the process until target is found or the search space is exhausted. Now what we will do, once you understand this, now we have to search on the right side of this. So we will move this low variable to this, right? So low variable will be updated to index 2. High will be as it is, which is 4. Now we will calculate once again calculate mid, which will come out to be 2 plus 4 by 2. So that is 3, right? So 3 index is this. So we will search here. So now middle element compares with the target. So it will return the index. In second pass, it will return the index 3, right? So in this way, this binary search method works. So what do you need to implement the binary search? A sorted array is required, must be in ascending or descending order. That doesn't matter. So example, suppose you have 2, 4, 6, 8, 10 array. Target value you require. Then you need to set indexes or variables as low, high and medium to keep track of current search zones. Then you will require loop to keep slicing the array in half. So I have already explained this example, but once again we will take one more example. So this is the array 2, 4, 6, 8, 10, 12, 14. Low is 0, high is 6 because there are 7 elements. Mid is 3. So 0, 0, 1, 2, 3. This is the mid. And we want to find out position of 10. Now since 8 is less than 10, search in the right half, right? We have updated the position of low to 4, right? Now low is 4, high is 6, new mid is 4 plus 6 by 2 is 5, ARR of 5 is 12. Since 12 is greater than 12, search on the left side. So you are going to repeating it again and again till the match is found. This is again binary search method code snippet in C language. Whatever logic we have used, this is set over here. Int low is equals to 0, m minus 1. This binary search function will receive 3 arguments: ARR, array, integer n, and target. Then again same logic is developed. Mid equals to low plus high by 2. And same is if else block is there, right? So you just go through the binary search method. I'm confident enough that you will understand this code after reading it. If you still do not understand, comment below. I will make another video on this to explain this binary search. Key points in the binary search: time complexity, base case is 1, that element is found in the middle itself. Worst case, log n, element is at the end or not at all present. Space complexity is 1 as no extra space is used. Works on only sorted list. This is the limitation. Efficiency, very efficient for large data sets, but not suitable for unsorted lists. Easy to implement using loop or recursion. It uses divide and conquer strategy. These are the key points to remember. And with this, we come to The end of this video lecture. So to summarize, linear search is simple and works on any dataset, but it is slow for large data. Binary search is much faster but requires the data to be sorted. So knowing when to use which method is key to design efficient algorithms. Thank you for watching this video lecture and feel free to reach out if you have any questions. See you in the next lecture. Have a nice day.